Hi guys. So in our last video, we talked about ways to describe solutions using the words saturated, unsaturated, and supersaturated, um, which are kind of qualitative in that, like, you're looking at a solution to see if you can see stuff at the bottom. You're adding an extra crystal to see what will happen, if it will dissolve or not. It's also kind of quantitative if you think about being given actual numbers and using table G to describe that solution. In this video, we're going to talk about more words to qualitatively describe solutions, and then formulas where we can use numbers to quantitatively say how much of a solute is it dissolved in a particular solvent. So first, let's look at these words, concentrated versus dilute. And I gave you guys a little picture here of a concentrated solution versus a dilute solution. Okay, and you can see the difference here as far as number of dissolved particles to go. So for concentrated, we're going to have a lot of solute, and for dilute, we have a small amount of solute. Now, with something like table salt, you're not going to be able to tell if something is concentrated or dilute by looking at it, because when table salt dissolves, it's clear. But if you have something like copper sulfate or some salt made with a transition metal that has a color, you can tell by looking at the solution if it's concentrated, because the color is going to be nice and dark versus dilute, which would have a nice light color. And you can even think back to our iced tea example. If I put in one little scoop and you put in 10, you're definitely going to see a color difference, and that's going to help us decide if we're concentrated or dilute. These are very good words to describe a solution, but they're also not very specific. So we're going to look at some formulas today that will help us quantitatively express how concentrated or dilute a substance is. Okay, so I kind of like to break these formulas up. If you look at this whole left side, these formulas are very similar to each other. We have percent, parts per million, and parts per billion. They're all similar in that we are doing that part over whole formula, whether they're giving us grams or volume. You take the small number and put it on top. That's your mass or volume of your solute. So I'll label that. So grams or milliliters of solute. And on the bottom, you have the whole solution. So that's your grams or milliliters of solution. And when I say solution, that's your solute and your solvent. So especially with the percent formula, guys, you have to be careful with what's given to you in the question. They're going to give you two numbers, but that big number, you really have to read what the question says. If it's just the water, then you have to add the solute and the solvent together to get your bottom number. If the bigger number given to you in the question is of the solution, then you can just plug that in on the bottom. To find a percent, you multiply by 100. To find parts per million, you multiply by a million. To find parts per billion, you multiply by a billion. The purpose of these two formulas are to give you a concentration of a very dilute solution, where you have a really small amount of stuff dissolved. So finding the percent, you're going to get a super small number, like in the decimals. I'm sorry, guys, this says solution. My stylus is like breaking. So these parts per million and parts per billions, these will give you numbers that make more sense to us. All right, over on the right side, we have molarity, which is moles of solute over liters of solution. If you're given anything other than those units, you need to convert before you plug into this formula. Mole fraction is similar to percent in that you're just doing moles of the component, which is like the part that's being asked about, over the total moles. That's your solute plus your solvent together. Just to give you guys like what these units are going to look like, molarity is abbreviated capital M. Moles is MOL, and liters is liters. For molality, which sounds very close to molarity, the unit is lowercase m. So that's what you're going to tell the difference. And the formula is moles of solute, which is moles, over kilograms. And this is just of the solvent, guys. So like just the water. Where up here with molarity, it's the liters of the whole solution, not just the water. So it's like very tiny differences that you just have to be careful with. A lot of information here. I want you to keep going back to this page as we read some examples and look at what formulas we should be picking. Okay, so let's move to example number 1. All right, a certain gas has a concentration in water of 6 milligrams per 100 grams of water. What is the concentration of the gas in parts per million? So guys, they're going to be specific about what formula you need to pick. They can't just like let you pick whatever you want. So because it says parts per million here, I want to use my parts per million formula. So parts per million equals, I'm always going to put my small number on top, but guys, I can't be comparing milligrams to grams. So before I go ahead and do that, I have to say, all right, if I have 6 milligrams, I know that there's 1,000 milligrams in 1 gram. So that's going to actually convert to 0.006 grams of this gas that's dissolved in this water. So that goes on top, 0.006. Okay, now guys, on the bottom, my whole is my whole solution. So when they give us a mass of 100 grams, it says that that's 100 grams of water. Is water my whole solution? No, it's not. So on the bottom, I really shouldn't just put 100. I should add the two things together, the solute and the solvent, to get my bottom number. Now, with parts per million, if you forgot to add the 0.006, that's really not going to make a huge difference because it's such a small number. And when you calculate your parts per million, you're going to get the same answer, whether you remembered to add or not. When you need to be careful about adding this bottom number is when it's a percent formula, because then your numbers are bigger and you're timesing by 100. So that's going to make a bigger difference. Here, if you forgot, you'd probably get away with it. So times a million, if you guys could just throw that in your calculator, make sure you're going to get the same thing I do. And we get 60. So guys, as far as like a percent would go, if I said 60% of my solution is solute, we would say like, oh, wow, that's pretty high. But in parts per million, you're comparing the number 60 to a million. So this is an actually very, very dilute solution. We do not have a lot of gas dissolved per unit of water. All right, next one. A student has 800 milliliters of a 6 molar sucrose solution. So we have some sugar water. How many moles of sucrose are in the sample? So guys, I want to look back at my formulas. I have milliliters, I have molarity, and I'm asked to solve for moles. So which formula has most of those things in it? right? It gives me molarity. It doesn't give me liters, but it gives me milliliters, and I can definitely convert to liters. And I'm being asked to solve for moles. So let's see what we got. Molarity equals moles over liters. So I'm going to plug in my 6 for molarity. I'm being asked to solve for moles, so I'm going to put my X up there. And for 800 milliliters, I'm going to do this over to the side. I know that in 1 liter, I have 1,000 milliliters. So I'm dividing this by 1,000, and I'm going to get 0.8 as my liters. So now I can plug that in here. How do I solve for X here? I'm going to cross multiply. So when I do 6 times 0.8, I'm going to get 4.8. And if I'm solving for moles, my unit is moles. So you have 4.8 moles of sugar dissolved in that solution, right? All right, next one. Okay, so let's underline what we're given. A student puts 116 grams of NaCl into 40 liters of solution, and we're being asked to find molarity. So guys, if they're asking you to find molarity, you have to use the molarity formula. So see, I know there's a lot of formulas, but it's really not so bad as far as like deciding what you're gonna pick. So moles over liters. All right, if I'm finding molarity, then molarity is my unknown. They're giving me liters. That's great. Do they give me moles? No, they do not. They give me grams, but we know if we have grams, we can convert to moles. So if I have 116 grams of NaCl, how do I know what 1 mole of NaCl is? I use the gram formula mass from the periodic table. So can you guys get your periodic tables out? You want to look up Na and Cl. Na has a mass of 23. Cl has a mass of 35. So that gives me a gram formula mass of 58. My grams cancel out, and I calculate 2 moles. So now that I know the number of moles, I can go ahead and plug that in up here. All right, and when I divide, I get 0.5 as my molarity, and the units for molarity are capital M. Okay. All right, example 4. A student has 40 grams of NaCl in 500 grams of water. What is the molality? Okay, so guys, this one is asking for molality, and if we scroll up to our molality formula, moles of solute per kilograms of solvent. So molality equals moles over kilograms. Okay, I'm solving for molality. That's what they asked me for. Moles of solute over kilograms solvent. So guys, my water is my solvent. I can't plug 500 in. 500 grams. I know that there are 1,000 grams in 1 kilogram. So I'm dividing by 1,000 first. So 0.5 is my kilograms. That's going to go on the bottom. Now, 40 grams, I have to convert that to moles. So I just did that in the problem above, but now they're giving us 40 grams. So if I have 40 grams of NaCl, I know that 1 mole of NaCl weighs 58 grams. I get that from the periodic table. So I need to think about what is 40 divided by 58. So I want to get my calculator out. 40 divided by 58 equals, let's do 0.69 moles. So now I could plug that in on top. And when I solve, divide by 0.5, I get 1.4 as my molality. All right. All right, guys, last example. And this is the toughest kind of question where they give us the percent of they give us the percent by mass of the solute, and they're giving us the specific gravity, which is the same thing as the density. So whenever they give you the specific gravity or the density, you always want to assume. I'm going to write this on the top so that you guys can see it. You need to make an assumption here. We need to assume 1,000 milliliters of solution. Okay, so let's start by taking this density that they gave us. I know that density equals mass over volume, right? Okay, so if my density is 1.3 grams per milliliter, right? That was given to me in the question. And I don't know the mass. This is where that assumption comes into play. I have to assume I have 1,000 milliliters of the solution. So when you cross multiply, you can figure out how many grams your solution is, which we're going to need. Okay. Now that I have the mass of my whole solution, I'm going to write that under here. Now I can say, okay, well, if they gave me the percent concentration, they gave me percent, I know the whole, then I can actually go ahead and solve for the part. So if I use my percent formula, I'm going to plug in the percent right here. So I'm going to make it 0.30 to get rid of the percent sign. All right, I don't know the part, but I know the whole solution weighs 1,300 grams. Now if I cross multiply again, I get x equals 390 grams. Now guys, what I just solved for, this is a solution of nitric acid, meaning that we have nitric acid dissolved in water. The whole solution is 1,300 grams. The 390 grams is just the solute. So the solute is nitric acid, which is HNO3. You guys remember how to write formulas for acids, right? Okay, so what can we do from here? If I know the mass of the whole solution and I know the mass of the solute, I can go ahead and find the mass of just the water by subtracting. So if 1,300 grams was my whole solution and I take away the solute, I know 910 grams is my mass of water. Okay, so you're going to see why we did all of this in the beginning, guys. And if you forget to do any of this stuff, then later on when you try plugging stuff into the formulas, you're going to realize you're missing something and you're going to have to go back and do it anyway. All right, so what's the first thing? The first thing they ask us to find is the molarity. So let's do that first. Molarity equals moles over liters, right? So the moles of the solute, my solute is HNO3, right? So I know that I have 390 grams of HNO3, and I can figure out what 1 mole of it weighs by looking on the periodic table. So I have H plus N plus 3 O's. If we look that up on the periodic table, we get that all comes to 63 grams. And if I divide, I get 6.2 moles of HNO3. All right. So guys, now I can go ahead and say, all right, well, the molarity is going to be 6.2 moles. Now, guys, I said in the beginning, we're assuming that my solution is 1,000 milliliters. For molarity, I have to convert that into liters. So 1,000 milliliters is 1 liter. And I get 6.2 as my molarity. All right, so molarity is done. Next is mole fraction of the solute. So for that formula, I need, let's see, mole fraction. I need moles of solute over total moles. So it's kind of good. I already know the moles of the solute. I solved for that up here, that's 6.2 moles. So that's going to go on top, 6.2. Now on the bottom has to go the total moles. So what else is in this solution besides HNO3? We have water in there. So I need to figure out how many moles of water we have to get the total moles. So we know that I had 910 grams of water, and I know that 1 mole of water weighs 18 grams. I know that from the periodic table. So if I do 910 divided by 18, I get 50.6 moles of water. So I want to do 50.6 plus 6.2. That's going to be my bottom number. Add that up first. Then you want to do 6.2 divided by that total. The mole fraction is going to be 0.11. And there are no units that go with this, guys, because our moles just cancel each other out. All right. Finally, they ask us to find the molality, which is our lowercase m. And it's moles of solute, which I already know is 6.2, over kilograms of the solvent. Not of the whole solution, guys. So I want to take my water, my 910 grams, and I want to change that to kilograms by moving the decimal 3 to the left. We're dividing by 1,000. Okay, so guys, this would be an example of like a very big part 2 question. Whenever they give you that density and give you a percent, you have all these steps to go through. All right. So that is it for today. We will practice this like crazy tomorrow, and have a great day, guys.